Hi everyone, we are going to learn about the next topic, which is the solid of revolution. A solid of revolution is generated by revolving a plane area about a line called the axis of rotation. Okay, so there are three methods in finding the volume. First is the disk method, which we are going to talk about today. This method is useful when the axis of rotation is part of the boundary of the plane area. Okay, so remember that it's only used, or it's very useful rather, if the axis of rotation is part of the boundary of the plane area. I will show you some examples later. Okay, we also have the washer method and the cylindrical shell method, which is the part 2 and part 3 of this video. Now let's talk about the disk method and how is it used. When the axis of rotation is the x-axis, so here the axis of rotation would be the x-axis. And the top of the area is given by the curve x is equal to, that's y is equal to f of x between x is equal to a and x is equal to b. Then the volume would be from a to b, pi y squared dx is equal to, so since pi is constant, pi will be outside the integral sign. Alright, and inside of it, which is your f of x, so your y would be in terms of x, squared dx. Now this would be your radius. Okay, same goes with y. So volume would be from C to D. So here our axis of rotation is the y-axis. So that would be pi from C to D, g of y squared dy. Alright, so why is it called disk method? We are going to talk about that in our examples. Example number 1, we are going to find the volume generated by y is equal to square root of x at x-axis bounded between x is equal to 0 and x is equal to 4. First, we are going to graph. You can use this method, letting the values so that we can plot and find the graph. But this y is equal to square root of x will look like this. Alright, and it's only bounded between 0 and 4. Alright, so therefore, hanggang dito lang siya sa 4. Now this is called the disk method because since the axis of rotation is at x-axis, so we are going to rotate here. Alright, so if we are going to rotate at x-axis from 0 to 4, what shape are we going to form? So if we are going to rotate that from this point to this point, so it will look like this. Diba? Mag-rotate. We are going to rotate. Oops. Okay, we have that point. So let's say this is an imaginary curve lang for our reference. So, and then from this point to this point as well, rotate. Since it's from 0 to 4, then rotate this one here and this one here and this one here. So guys, you can see that this is a three-dimensional shape, right? So in plane area, you're going to deal with a plane shape only. But here in volume, since we are dealing with volume, and so we are talking about the three-dimensional. So if you are going to look at it, it's like if you're going to draw it in this form, so it will look like this. It's like a hat, right? Sorry, I'm really bad at drawing, but I hope you can foresee or imagine. And we are going to find the volume of this point only. Okay? So since we already have the limits in x, which is 0 and 4, therefore, we can use, or we can already find the volume from 0 to 4, pi, and then dx. So we're going to look for, this is f of x, right? The f of x, or the radius. So what is f of x here? Now, this is our problem. Actually, the f of x is just y. This is y, right? And our value of y is just equivalent to square root of x. Therefore, that is square root of x squared dx. So therefore, you will have pi from 0 to 4 x dx. That's pi x squared over 2 from 0 to 4. Pi, so 4 squared over 2 minus 0 squared over 2, so that's obviously 0. So pi 16 over 2 minus 0. So 16 over 2 is 8. Therefore, you have 8 pi cubic units. This is your final answer. So therefore, the volume of this shaded region here is 8 pi cubic units. Okay? Alright, now let's proceed with the next example. So this one is kind of complicated since we are going to revolve or rotate at y is equal to 4. So find the volume of the solid generated by the function y is equal to x squared about y is equal to 4. So we are going to rotate at y is equal to 4, bounded by the region x is equal to 0 and y is equal to 4. We know that y is equal to x squared is just a parabola, right? So parabola. Oops. Sorry. Okay, that's a perfect one. All right, and the region would only be from 0, and this is, for example, 4. So therefore, the region bounded by what we're going to look for is just this one, right? Okay, now since we are asked to rotate at y is equal to 4, therefore we are going to rotate here, so it will look like this. So parang ganito siya nangyayari. No, it looks like a disc, right? Since this is the center. So imagine a disc. That's why it's called a disc method. Okay, so this is okay, I'm really bad at drawing, so I'm sorry. I hope you can imagine a disc in there. Okay, now we have y is equal to 4 and x equals to 0. So this again right here is y is equal to 4. So gawin natin ng ibang color. So ayan ha. So from this 0, then this is 4. What is the first step that we are going to do? We first need to find the point of intersection here. How to find the point of intersection? We know that to find the point of intersection, we equate both sides. So 4 is equal to x squared. So equate natin si y is equal to 4 and this one. So that's 4 is equal to x squared. Therefore, x would be positive and negative 2. Alright, so therefore, this is positive 2. This is 0. So we don't know the y value for that. For this, we know that it's 4. For this one, that's obviously 0, 0. Okay? So therefore, we can now find the volume of this here. Okay? So to find the volume for that one, that would be from 0 to 2, right? Now our problem is, this is 4. right? The whole part of this one is 4. We're just going to, we need to find only this point here. The region bounded here only, right? So this is the radius or the f of x. How do we do that? So obviously this one would be y, correct? And this is obviously 4. So 4 minus y is the f of x, or the radius. And since this is in terms of x, this is dx, we are going to let y in terms of x, which is x squared. Therefore, our radius or our f of x here would be 4 minus x squared. Remember again that only the region bounded by the curve and the line y is equal to 4. Okay, so therefore, oh sorry, we forgot to square it. So how do we find the volume for that one? Now let's just, how do you call that? Distribute, or yeah, let's distribute 4 minus x squared squared. So therefore that would be 4 minus x squared. 4 minus x squared. So that is 16 minus 4x squared minus 4x squared plus x to the power of 4. So that's 16 minus 8 x squared plus x to the power of 4 dx. So that is 16x minus 8x cubed over 3 plus x5 over 5 from 0 to 2. Volume is equal to pi 16 times 2 minus 8 2 cubed over 2. Sorry, that's 3 plus 2 to the power of 5 over 5 minus, obviously that would be 0, right? Therefore, that's pi times 32 minus 8 times 2 cubed over 3, that's 64 over 3 plus 2 to the power of 5 all over 5. That's 32 over 5. Therefore, our final answer would be 256 over 15 pi cubic units. This is our final answer. Now let's go to example number 3. Okay, so the curve would be y is equal to 2 minus x squared, region enclosed by that curve. Okay, so curve y is equal to 2 minus x squared and y is equal to 1, and then rotate about y is equal to 1. Sige. Alright, so let's try to draw the graph for that one. This is negative. Obviously, this would, and this is x, right? So it's negative and it's x. So this is a parabola which is going downward because of the negative sign. And it will start with 2. Y is equal to 2. So it will look like this. Oops. Yan. Alright. Okay. Enclosed by that curve and y is equal to 1. So therefore, that point and this. So this is the plane area. Right. The question is to find the volume. Okay. We're going to find the volume of the region bounded. Now, if we are going to rotate, it will look like this na. So, that. Ayan. Alright. So we are going to find the volume only of this. So, yan, yan. Alright, so just imagine, okay? You guys, I know you're imaginative and how you can draw the picture in your minds. So we're going to find first the points of intersection. So this point and this point. How are we going to do that? Again, let's equate both sides. So equate the y is equal to 1 with the curve y is equal to 2 minus x squared. So 1 is equal to 2 minus x squared. So x squared is equal to 2 minus 1. Therefore, x is equal to positive negative 1. So this is 1, 1, and 1, negative 1. Wait, it's negative 1, positive 1 rather. Alright. So, since we already have, or we have the points of intersection or our limits, which is from negative 1 to 1 and then pi. Okay, so we now need to find the f of x or the radius. So how are we going to find this point only? Ito lang. Na this curve right here, this curve is equivalent to 2 minus x squared, right? The whole of that. So this one is again your y, or which is equivalent to 1, right? So 1 yan siya. So this is y is equal to 1. Now if we are going to subtract the whole this and this, that is our f of x or our radius. Therefore, we now have 2 minus x squared minus this one, which is 1, then squared. So that would be pi from negative 1 to 1. 2 minus 1, that's 1 minus x squared, squared dx. Okay, so that's pi. Alright, let's simplify to make it integrable. To make it, or to make the function, or to integrate the function, now we are going to distribute. So therefore, that is 1 minus 2x squared, tama, plus x4, then dx. Alright, so that's pi, negative 1 to 1, so that's x, sorry, let's integrate it already, so that's x minus 2x cubed over 3 plus x5 over 5 from negative 1 to 1. Okay, so that is from pi 1 minus 2/3, so that's simply 2/3, right? So that's positive 1 over 3, and this is 1/5 minus, this is negative 1 minus, this is negative 1 raised to cube, that's simply negative 1 times 2, magiging positive, minus 1/5. Simplifying our expression, so this is 1 minus 2/3 plus 1/5, that's 8 over 15 minus that's plus 8 over 15. So therefore, your volume is 16 over 15 pi cubic units. Now this is our final answer. So So guys, if you have any questions, you can ask me in our group chat or in the forum that will be posted on Blackboard, or you can message or email me. Okay, so please, I would gladly accept your questions about this lesson. Activities will be posted soon. Thank you so much for listening. Hope you have a great day. Goodbye.